Good morning, all of you. Our next concept is the point of intersection of ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 is, just remember, point of intersection means for suppose if these are the two pair of intersecting lines, this point, okay, so is hf minus bc by ab minus h square gh minus af by ab minus h square. Just remember, okay, so it is that hf minus bc by ab minus h square gh minus af by ab minus h square. So if you know the differentiation in physics already we have, so without the differentiation so they won't start first year syllabus. So you know very well what is the differentiation of x power n, that is n into x power n minus 1. Differentiation you will start in next month, okay, in mathematics. So until you remember this formula, d by dx of x power n is equal to n into x power n minus 1. This is differentiation of x power n. If you remember this formula, so that means this point of intersection you get by using dou f by dou x is equal to 0 and dou f by dou y is equal to 0. Here dou f by dou with respect to partial differentiation, with respect to x, remaining all terms are constants. Only x terms, only the variable term. With respect to y, except y terms, all terms are constants. So we know differentiation of constant is equal to d by dx of any constant is equal to 0. But d by dx of some constant into x power n is nothing but not 0. It is in the multiplication and it is the variable term. In this case, c is the constant you have to write outside and go for differentiation of x power n, that is cn into x power n minus 1. You remember, only constant is there, then it will be 0. Okay. See here, what is dou f by dou x? This one you do. This is, let us take, this is some f. F as ax square plus 2. Generally we denote with s. So then it is dou s by dou x, dou s by dou y. So this has to differentiate with respect to x and partial differentiation. So remaining all terms except x terms are zeros. So ax square. So that means 2ax. Because a is the constant, x square differentiation is 2 into x power 2 minus 1. That is 2ax plus here 2hxy is there. So here 2h and y, these three are constants like c. So those three you write 2hy here. And x differentiation, you remember d by dx of x is equal to 1. Because x power 1 is there. So 1 into x power 1 minus 1. X power 1 minus 1 is 0. So 1 into, sorry, numerator is 0, 1 minus 1 is 0. Anything power 0 is 1. So 1 into 1 you get. So next plus by square constant 0. Totally there is no x term. 2gx. Here x is the variable, 2g is the constant. So 2g into x differentiation 1 only. Next one, 2fy constant, c is the constant. So this is the one equation. And the second one is dou s by dou y is equal to 0. So ax square term is 0 because there is no y. Here 2hxy, here 2hx is the constant. So 2hx is nothing but 2hx into, similarly if you differentiate with respect to y, so d by dy of y. With respect to y means you have to write d by dy of y. Same, this also 1. With respect to y, it is the variable. Okay, so plus by square, same y square differentiation is 2y, so 2by plus 2gx is the constant, 2f is the constant, y is the variable, differentiation of y is 1, so 2f. C is the constant, that is 0, is equal to 0. Here what can you take? Here also what can you take? 2 is the common, this 2 if you take outside, ax plus hy plus g is equal to 0. Other words, you can write ax plus hy plus g is equal to 0. So this one you take as 1. Similarly, if you take 2 common here also, hx plus by plus f is equal to 0. So 2 transpose that side, you get hx plus dy plus f is equal to 0. If you solve these two equations, solve 1 comma 2 by elimination method or cross multiplication method or substitution method. I am doing here cross multiplication method. X, y constant. So x, y constant, you start from y coefficient, that is h, g, a, h. In this equation, start from here b, f and h, b. So what we have, x by h of minus this cross multiplication minus bz is equal to y by gh minus af is equal to 1 by ab minus h square. If you want to find out x, what is here? To equate these two, x is equal to h of minus bz by ab minus h square, and equate these two, y is equal to gh minus af by ab minus h square. This numerator cross multiply. Okay, this denominator will goes to here. So you get h of minus bz by ab minus h square, that is the x coordinate, and gh minus af by ab minus h square, that is y coordinate. Next problem. If the straight lines xy minus x minus y plus 1 is equal to 0 and ax plus 2y minus 3 is equal to 0 are concurrent, then a is equal to. See here, concurrent means it is possible by 3 lines or more than 3 lines. Here they given clearly one line. Here it is the second degree equation in x and y. So it is nothing but pair of straight lines. First you solve this one. That means we have to get the two pair of lines by factorization method and solve the point. That point will be lies on this line, because of from this one you get the two lines. Concurrent means this third line also on this point one. That means this third line also passes through this point only. So solving these two, but suppose these are the two lines from this one, 1, 2. It is the third one. So the point of intersection of 1, 2 lies on third one. Substitute in the third equation, in the given equation, you get the value of a. Okay. See here. xy minus x minus y plus 1 is equal to 0. Can you factorize it? So you can take x common here, that is y minus 1. Here minus 1 common, you have y minus 1 is equal to. So take y minus 1 common, y minus 1 into x minus 1 is equal to 0. So this means first equation is y minus 1 is equal to 0, and second equation is x minus 1 is equal to 0. So this means y is equal to 1 and x is equal to 1. This is nothing but its point of intersection only. Because of y is equal to 1, x is equal to 1. So y is equal to 1. Y you take here. This is the line passing this point 0, 1. And x is equal to 1 will be, if you take this is 1, 0, this is the point. So this point of intersection is nothing but 1, 1 only itself. So what is the point of intersection? Therefore x, y is equal to 1, 1. Substitute this x, y is equal to 1 in given equation ax plus 2y minus 3 is equal to 0. Substitute, because these three lines are concurrent. Substitute x, y, that means 1, 1 in ax plus 2y minus 3 is equal to 0. Then what you have? So a into 1 plus 2 into 1 minus 3 is equal to 0. That means a plus 2 minus 3 means minus 1 is equal to 0. That means a is equal to 1. Next problem. Square of the distance from origin to the point of intersection of the lines 6x square minus 5xy minus 6y square plus x plus 5y minus 1 is equal to 0 is. See here, what is asking the question? Square of the distance from origin to the point of intersection of the given pair of straight lines. That means this is the pair of straight lines. It is not crossing through origin. See here, maybe origin is here. So he is asking first you have to find out the point of intersection of this one and find out the perpendicular distance from this point to this point. That means here distance from this point to this one, and take the square of that one. That is your required answer. So if you use the previous formula, what is that? For ax square plus 2hxy plus by square plus 2zx plus 2fy plus c is equal to 0. The point of intersection pi is equal to what is that? h of minus bc by ab minus h square gh minus af by ab minus h square. So according to this, what is h value, what is a value, what is b value like that? So here a is equal to what? 6. 2h is equal to minus 5. That means h is equal to minus 5 by 2. And b is equal to minus 6. And c is equal to minus 1. So this is for 2zx. So 2z is equal to 1. This is 2f. 2f is equal to 5. Okay, substitute here what you have? H of h means minus 5 by 2 into f means 5 by 2 minus b means minus 6 and g means 1 by 2 by ab minus h square, that is 6 into minus 6 minus h square, that is minus 5 by 2 whole square. This is x coordinate computed. Now y coordinate gh. What is g here? 1 by 2. H means what here? Minus 5 by 2. Okay. Next, minus a means what here? 6. F means what here? 5 by 2. By ab minus h square. 6 into minus 6 minus 5 by 2 whole square. So this becomes to minus 25 by 4 minus it is minus into minus plus 6 by 2. 6 by 2 you can write as 3 directly. By minus 36 minus 5 by 2 whole square, 25 by 4. Here minus 5 by 4 minus 2, 6, 3 times going. So 3 5s are 15 by minus 36 minus 25 by 4. So this gives 4 3s are 12 minus 25 plus 12 minus 13 by 4. Here 36 4s are 3 4s are 12, 6 4s are 24. So 144 minus 144 minus 25 minus 144 minus 25 minus 169 by 4. This is 15 4s are 60. That is minus 65 by 4. And same minus 169 by 4. So 4s will get cancelled. So 13 in 169 13 times going. This is 1 by 13. Minus minus get cancelled. Next one here 65 by 169. Same 13 here in 65 5 times going and minus minus get cancelled. 5 by 30. So this is the point. From this point, this is nothing but what is that? This point is nothing but 1 by 13 comma 5 by 13. So from this point to this point, perpendicular distance, square of the perpendicular distance. Generally, what is the formula? Distance from 0 comma 0 to x comma y is root over x square plus y square. What is asking? Square of this one. Square of this one is nothing but root square get cancelled. So now we want square of distance. Square of distance is equal to, this is act as x comma y. This is 0 comma 0. So x square plus y square only. So that means 1 by 13 whole square plus 5 by 13 whole square. That is 1 by 13 is 1 by 169. 5 by 13 is 25 by 169. So 25 plus 1, 26 by 169. So 26 means here 13 2 times y. So and 2 by, and here 13 times 2. That is answer is 2 by 13. Next theorem is very important. This is important for IPE and objective also. So just remember the theorem statement. See here, equation of pair of straight lines x square plus 2hxy plus by square is equal to 0. Sorry, here equation of pair of angular bisectors. So you rewrite the theorem. Equation of pair of angular bisectors. So we are going to find these angular bisectors. Angular bisectors between the pair of lines. Ax square plus 2hxy plus by square is equal to 0 is h times of x square minus y square is equal to a minus b into xy. See here, proof. This one we are going to prove by using straight lines. So in straight lines also we have angular bisectors. So first you write this one as pair of straight lines. How can you write? Ax square plus 2hxy plus by square you can write as, it is not passing through origin. So you take the two straight lines which are not passing through origin. Which are not passing through origin means there are no constants. That means those two lines doesn't have constants. That means L1x plus M1y into L2x plus M2y. See, these are the two pair of straight lines. So this is nothing but this one. So that means this is the first line L1x plus M1y is equal to 0. This is second line L2x plus M2y is equal to 0. Now we are going to find out the pair of angular bisectors. Okay, so we are going to find these equations by using straight lines. So these are the two lines. What is the angle bisectors of a pair of straight lines? So we know very well. That means for pair of angular bisectors of a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 is a1x plus b1y plus c1 by root over a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 by root over a2 square plus b2 square. So use this formula to find the pair of angular bisectors of these two lines. Pair of angular bisectors of these two lines is nothing but pair of angular bisectors of given this one. But it was you have to consider in our own coefficients L1, M1 and M2. So but we have to prove this one in terms of A, 2H and B. So first we have to compare the corresponding coefficients. You know very well what is that? Very clearly, x square coefficient L1 and 2 is equal to A is equal to L1 and 2. And similarly, 2h xy coefficient L1 and 2 plus L2 M1. L1 M2 plus L2 M1. and the y square coefficient, that is m1, m2. That is here b. B is equal to m1, m2. So now come to this one. So use this formula for this one. What do you have now? Pair of angular bisectors. Pair of angular bisectors is equal to what it is? L1x plus m1y by root over L1 square plus m1 square, because there is no constant, so no need write, is equal to plus or minus L2x plus m2y by root over L1 square plus m1 square. Just cross multiply. So this implies L1x plus m1y, or you write here plus or minus right here. Okay? So if you write plus or minus L1, transpose this side also, you get plus or minus. L1x plus m1y by root over L1 square plus m1 square plus or minus L2x plus m2y by root over L1 square, sorry, here it is L2 square, it is m2 square. L2 square plus m2 square is equal to 0. So now this one, cross multiply. What you have? L1x plus m1y into root over L2 square. In other words, we do one thing. Squaring on both sides also we can do. That is also one of the things. After that, to cross multiply it. That is also one of the best method. So first you go for squaring on both sides. So what you have? L1x plus m1y whole square by L1 square plus m1 square is equal to L2x plus m2y whole square by L2 square plus m2 square. Now you cross multiply it. What you have? L1x plus m1y whole square into L2 square plus m2 square is equal to L2x plus m2y whole square into L1 square plus m1 square. Expand it. What you have? This implies L1 square. Okay, I am writing here only. So this is L1 square x square plus m1 square y square plus 2L1 m1 xy into L2 square plus m2 square is equal to, here this one also we can write L2 square x square plus m2 square y square plus 2L2 m2 xy into L1 square plus m1 square. This is the multiplication. So now you multiply again. What you have? L1 square, L2 square, L2 square, and x square is there. And the same this one multiplied to m2 square. That is L1 square, m2 square, again x square. So with first term, these two terms completed. Now go to second term. Plus m1 square and L2 square y square plus m1 square m2 square y square plus, next what you have? 2L1 m1 xy L2 square. That means 2L1 m1 m2 square xy plus, next one 2L1 m1 m2, that means first this is 2L1 m1 L2 square. First you write L2 square here. Next 2L1 m1 m2 square xy. So this side completed. Now I am writing here second side, right side. Same L2 square x square into L1 square. That means L1 square L2 square x square plus L2 square x square into m1 square. That is L2 square m1 square x square plus, next this term to these two terms, m2 square L1 square into y square plus m2 square m1 square y square. plus now this term to these two terms. 2L2 M2 XY L1 square. That means 2L1 square L2 M2 XY. Next 2L2 M2 M1 square plus 2L2 M2 M1 square XY. Okay, see here what are the cancelled terms? These two terms cancel. And L1 square M2 square X square not cancelled. Next M1 square L2 square Y square is there, and M1 square M2 square Y square is there. Where is M1 square M2 square Y square? These two get cancelled. Next 2L1 M1 L2 square XY. So is there any cancellation? Next 2L1 M1 M2 square XY. XY terms once you observe L1 M1 M2 square. There is no term. Here L1 M1, so no terms. So these are all the four terms cancelled. Remaining terms transposed to one side. So now we have here x square term is there. Here also x square term is there. That x square, if we take common, what we have? L1 square M2 square minus L2 square M1 square. Next y square terms we have. Here one term, here one term. So y square common. So M1 square L2 square minus what is here? M2 square L1 square. Next xy terms. How many are there here? Plus if you take xy term common, 2L1 M1 L2 square plus 2L1 M1 M2 square into next this transpose left side, what you have? This is minus 2L1 square L2 M2. This is minus 2L2 M2 M1 square is equal to 0. So here we have L1 M2 plus L2 M1. But here L1 M2 whole square, L2 M1 whole square. Just I am using the formula A square minus B square is equal to what is that? A plus B whole square minus sorry. You write here A square minus B square formula A plus B into A minus B, not A minus B whole square. It is A square minus B square, A plus B into A minus B. So A plus B means L1 M2, that means x square into L1 M2 plus L2 M1 into L1 M2 plus L2 M1, like that you can write. In other words, you can write one more term. Directly you can write. It is L1 M2 square L2 M1 whole square. It is M1 L2. First one here. Here M2 L1. Second one is here. If you take minus common, these two terms will be same. So that minus you take common outside, then it becomes to minus, and take this one as common. Okay, then what you have? L1 square M2 square minus L2 square M1 square. If you take common here, x square is there. Here minus y square, because to change this term as this term, here you want to take minus common. After taking minus common, this is minus y square into L1 square M2 square minus L2 square M1 square. So then after changing the term, these two terms we can take outside, that is this term. Plus here what you have? Xy into see plus 2xy. 2 also we can take. And one more term, what can you take common here? L1 M1. This is also L1 M1. If you take L1 M1 common, what is L1 M1? So there is no L1 M1. Okay. So here this is what is this term? This is L2 square. Okay, this term here L2 square. 2L1 M1 L2 square. 2L1 M1 M2 square. 2L1 square L2 M2. 2L2 M2 M1 square. What can you take common from these four terms? Is there any term common? See here. 2L1 M1 common, what you have? L2 square plus M2 square. In the same way, 2 m2 common, what you have? L1 square minus 2 L1 L2 common, what you have? Minus L1 square, that means L1 square plus M1 square. What can we do with the L1 square and this L2 square plus M2 square and L1 square plus M1 square? Is there anything is there? No. What we have to do, this is A minus B into X, something we have to do. So here we should get A minus B only. What is A minus B? A is equal to L1 L2. B is equal to M1 M2. So we have to take L1 L2 common and M1 M2 common. See here, this one once we observe, here L1 L2 is there. After taking what we have, that one we have to take outside. Okay, and we have L2 M2 also is there. Where is L2 M2? Sorry, L2 not L2 M2. M1 M2 we want. Where is M1 M2? Here M1 M2 is there. Here also M1 M2 is there. So that means where we have L1 L2 to take common, that from those two terms we have to take L1 L2 common. Okay, so after 2 common from all these 4 terms, we have, first we have to take L1 L2 common. L1 L2 into, after taking L1 L2, what we have? M1 L2 is there left out. M1 L2. And from here, if you take L1 L2 common, what you have? L1 M2. So minus L1 M2. Similarly, from these two terms, what can you take common? M1 M2 you can take common. Take M1 M2 common. So if you take M1 M2 common, what you have? L1 M2 is there, and here L2 M1 is there. Minus L2 M1 is equal to 0 into xy. This board is visible to you or not? Now it is visible to you. Okay, see here all terms I have written. Okay, of course here last term is not visible before. My 2L2 M2 M1 square x square. Here what I am writing here, M1 M2 into, after taking M1 M2 from these two terms, what you have? L1 M2, and here L2 M1 into xy is equal to 0. Okay, clear? So now we have, what is the common from all these terms? Here you can write L1 M2 plus L2 M1 into L1 M2 minus L2 M1. Here also you can take minus, if you take minus common from this one, you can write L1 M2 minus L2 M1. Here also directly L1 M2 minus L2 M1. So totally this one factorization, what can you write? L1 M2 plus L2 M1 into L1 M2 minus L2 M1. What you have this second factor, from all these terms you take this L1 M2 minus L2 M1 common. So after taking common, what we have, that is so L1 M2 minus L2 M1 take common. Left over here L1 M2 plus L2 M1 is there, and here x square minus y square is there. Yes, plus 2 into. Here what is the common to take? Here M1 L2, actually we are taking L1 M2 minus L2 M1. Here L1 M2 is the second term, L2 M1 is the first term. So take minus common. Okay, then it becomes to minus L1 L2. Take minus common and take this one common. Okay, next here directly we have same procedure, plus M1 M2. So we have this is equal to xy is equal to 0. So this one transpose to denominator, 0 by anything is 0. Now we have L1 M2 plus L2 M1 is 2h into x square minus y square plus 2 into L1 L2 means a minus a plus M1 M2 means b into xy is equal to 0. Now you take 2 also common, or this is the 2 common, you have h into x square minus y square plus minus a plus that is b minus a into xy is equal to 0. So this 2 also transpose this way, 0 by anything is 0. Now we have h into x square minus y square is equal to this plus term transpose this side minus, and that minus multiplied then what we have? Minus of b minus a becomes to a minus b. So this is nothing but a minus b into xy. So h into x square minus y square is equal to a minus b into xy. If you practice, once you practice it, it is very easy. Actually, because of some board problem, I have written here little bit small letters. So please try to understand. Okay, but this is the procedure. Once you do in your own way, the book. Okay, practice it, you get the clear answer. Have any doubt? Please raise your doubt. No problem. Next, based on above theorem, one application. One. The equation of angular bisector of S is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 is, see here in previous theorem. So what is the formula? Actually ax square plus 2hxy plus by square is equal to 0. We have h into x square minus y square is equal to a minus b into xy. Very clear. Same way, first for this one we have to find out the point of intersection. So first point of intersection of s is equal to 0 we find out. Let it be some alpha comma beta you take. Because of in previous the point of intersection of ax square plus 2hx plus by square is all in 0 comma 0. So no need to find out that one here, but you should find out the alpha comma beta and write in the same structure. See, it is 0 comma 0. How it will be? X0 h of x minus 0 whole square minus y minus 0 whole square is equal to a minus b into x minus 0 into y minus 0. You can write. Same, if you want to substitute 0, if you simplify again you get. Same if it is alpha comma beta, same in the place of 0, what you have to substitute? Alpha and beta. That is our required formula. Is what is that? H into x minus alpha whole square minus y minus beta whole square is equal to a minus b into, in the place of x substitute x minus alpha into, in the place of y substitute y minus beta, where alpha comma beta is point of intersection of s is equal to 0. Okay. So next application, if ax square plus 2hxy plus by square is equal to 0 bisects angle between the coordinate axis then a plus b whole square is equal to h square. See here, if ax square plus 2hxy plus by square bisects angle between the coordinate axis, that means this is the coordinate axis, okay, x axis, y axis. If this ax square plus 2hxy bisects the coordinate axis, then the condition is a plus b whole square is equal to h square. So very clear answer. The angular bisector of coordinate axes are nothing but one is x is equal to y, another one is x is equal to minus 1. Very clearly, if it is the angular bisector of the coordinate axis, this one you can write as ax square plus 2hxy plus by square, you can write as x plus y. X is equal to minus y is x plus y into x minus y, you can write. So very clearly these two are the factors. Okay, so x plus y is one of the solution of this one very clearly. So what can I write? That means x plus y, if you take case 1, x plus y is equal to 0, this is the one of the equation. So what can I write? X is equal to minus y. So x is equal to minus y, substitute in this one. So that implies what can I write? A into x. X means you can write minus y whole square plus 2h into x means minus y you write into x plus by square is equal to 0. So here also y only. In the place of y, y. In the place of x, just substitute minus y. And what you have, this is minus y square means y square. Minus y into y, y square. That is minus you get, and it is y square. So y square if you take common, what you have? A minus 2h plus b into y square is equal to 0. 0 by y square is 0 only. So we have a plus b is equal to 2h. This is one of the equation. Case 2. If it is angular bisector, x is equal to y. That means x minus y is equal to 0 or x is equal to y. So this x is equal to y also satisfies this equation. So what can write? This is a into y square plus 2h into y into y plus by square is equal to 0. Take y common, we have a plus 2h plus b is equal to 0. So 0 by y square is 0. After that you write a plus b is equal to minus 2h. This is second one. The combined equation of these two what you get? So from 1 comma 2, combined equation. C means combined equation is a plus b into a plus b is equal to it is equal to 4h square. Sorry. Okay, a plus b into a plus b is equal to 2h into minus 2h. So squaring that means what can I write? A plus b whole square is equal to minus 4h square you got here. In other words, you could write this one as one thing. So don't write combined equation. To get a plus b whole square is equal to 4h square. One thing you can do, combined equation of 1 comma 2 don't write. Here just from 1 comma 2 what can you take? A plus b is equal to either 2h or minus 2h because we have 2 here plus 4h. Okay. See what can I write? A plus b is equal to plus or minus 2h from 1 comma 2. That one you have to consider. Okay. So then squaring on both sides what we have? A plus b whole is equal to 4h square. This is required. If you write the combined equation, a plus b whole square is equal to minus 4h square you get. But square of any number never be negative. So that is the wrong concept. So that's why you have to consider a plus b is equal to 2h and a plus b is equal to minus 2h. Totally a plus b is equal to plus or minus 2h. Squaring on both sides, we have a plus b whole square is equal to 4h square.